In this video, I'm going to explain rational numbers and ordering rational numbers. Firstly, we define what is rational number. The terms, when we write in fractional form, a over b, a and b here, it must be integer, element of z here, it's shown also. Then the term is called rational number. Q is representing a rational number set. Here the important part, b cannot be equal to 0, because when b is equal to 0, the rational number is undefined going to be. And we have the negative of them. When we have the rational number which is smaller than 0, that's negative rational number it's going to be. And we are going to show with Q. Q is the rational number set notation, and we are going to show the negative rational number by Q minus. Okay, and here we have the natural number set, integers, and the Q is enlarging the z and natural numbers. So when we write with the subset form, natural number is subset of z and z is subset of Q, it's going to be. Here, while we are notating the negative rational numbers, here it's given like minus 5 over 4. Minus 5 over 4 is going to be equal to minus 5 over 4 or 5 over minus 4. These all terms, they are going to be same number, which means this minus sign you may give to numerator or denominator. Okay. Now, how to show them on the real number line. Here 5 over 6 and 11 over 7. From the fractions topic, we know how to, 2 lessons before we learned that one. Between 0 and 1, we are going to divide into 6 equal parts, 6 subunits. And then we are going to take if it is 5 over 6, the fifth one. So 1, 2, 3, 4, 5. This is the fifth equal part. So the the fraction is 5 over 6. It's going to be. Or the next one is 11 over 7. Here we are dividing by between 0 and 1, 7 equal part, and 1 and 2, 7 equal part. And from the beginning, if we count 1, 2, 3, 4, 5, 6, 7. Pardon, I count from 0. I need to count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is the 11th part. And this is the 11 over 7 it's going to be. At the same time, when you simplify or when you convert to mixed number, it's going to be 1 and 4 over 7. 1 and 1, 2, 3, 4. 4 over 7 it's going to be. Here, the new part for us, we know from the integers, when you draw the real number line, this part shows the positive part, and this part shows the negative part, and the mid part is 0, and it's natural. When we count to this side, it's going to be 1. When you count to this side, when you write to this side, it's going to be minus 1. And when you write the 2 here, minus 2, if you remember, it was at this part. So for the rational numbers between 0 and when the number is negative, it's going to be between 0 and minus 1 this time. And you are going to start from to this side. You are going to count from the first one. It should be here, and from this part you should start to count. And this is minus 3 over 7. We should divide into 7 equal parts, and I'm going to accept 0. I'm going to start to count from 1, then 2, then 3. This is the negative 3 over 7 it's going to be. Okay. For comparing and ordering the rational numbers, we have one simple rule here, cross product rule it's called also. A over B and C over D we have, and if when you multiply A by D and B by C, the result, if AD is bigger than BC, it means that A over B must be bigger than B over C over D. Vice versa, Also, we may say here, when you say A times D is less than B times C, it means that A over B is less than C over D. It's going to be. So for us, it's very easy to compare 4 over 7 and 5 over 9. 4 times 9, it's equal to 4 over 7 and 5 over 9 I'm giving. Here 4 times 9 I'm writing here. 5 times 7 I'm writing here. 4 times 9, 36. 5 times 7 is 35. And 36 is bigger than 35. So 4 over 7 is bigger than 5 over 9 it's going to be. Or 1 over 4. 1 over 4. It's bigger than, actually smaller than it's going to be, because I multiplied 6 times 1 is equal to 16. 4 times 5 is equal to 20. So 20 is bigger than 16. That's why 5 over 16 must be bigger than 1 over 4, or 1 over 4 is less than 16 over 1 over 4 is less than 5 over 16. It's going to be, actually here the operations are given here, how to do that one. It's written here. That's why I showed them here. Okay, now for the negative number, what we are going to do for the negative number, when we know that 1 is less than 2, but when you write the negative of them, -1 and -2, we know that the operation should change. The bigger, this is less than, must be bigger than, -1 is less than -2. So if I give the terms like -4 over 7 and -5 over 9, I'm going to multiply them 9 times 4, 4 times 9, and it's going to be equal to, here, -4 times -9, which is equal to -36, and -5 times -7, -5 times -7, one of them I'm going to choose, I'm giving to numerators, so -4 and -5 I said, 7 and 9, now they are positive, and -36, -5 times -7 is equal to -35, so we know that -35 is bigger than -36, so we are going to do inverse operation here. Normally 36 is bigger than 35, but when we put minus sign, -36 is less than -35, so everything what we are doing for the negative, it's going to be inverse with respect to greater sign. Okay, here are some exercises. When the numerators are same, when the denominators are same, when none of them is same, we are going to try to compare. These are, here the property is written up at upper part. If the rational numbers have a common denominator, then the rational number with the biggest numerator is the biggest number. Biggest numerator with the biggest number. So which one has the biggest numerator? 9 over 7. So 9 over 7 is the biggest one. Then, or I can write from the smallest to greatest, that's better I think. 1 over 7, this is the smallest denominator. Then smaller than 5 over 7 is smaller than, yes, 6 over 7 smaller than, 9 over 7 is going to be. Here, if the numerators are same, we are going to write the smallest denominator is the biggest number. Smallest denominator is the biggest number. So if I start with the biggest denominator, which is 11 over 13, is less than the second bigger is 12. So 11 over 12 is less than 11 over 5 is less than 11 over 3 is going to be. Okay, here we don't have common numerator or denominator. When we are applying the ordering rules here, we should make something same. Then we can compare. Numerators must be same or denominators must be same. For this one, we should find, I'm going to use for this question common denominator. I'm going to enlarge the number by the same number and I'm going to make the denominators same. Here, least common multiple we can use, and when I check the 4, 3, 6 and 12, the least common multiple is 12. I can multiply this number by 2, I can multiply this number by 4 and this number by 3, so numerator and denominator, when I multiply by 3, I'm going to get this number 3 over 4. 3 over 4 is equal to, when you multiply by 3, it's going to be equal to 9 over 12. Or when I multiply 2 over 3 by 4, 2 over 3 by 4, here it's going to be equal to 8 over 12. Okay, when you multiply by 2, 5 over 6, when you multiply by 2, it's going to be equal to 10 over 12. Now I'm rewriting the numbers. 3 over 4, 2 over 3, and 5 over 6, and 7 over 12 becomes 9 over 12, 9 over 12, 8 over 12, 10 over 12, and 7 over 12. So when the denominators are same, the biggest numerator is the biggest number. So smallest denominator is 7, that's the smallest number. 7 over 12 is less than 10 over, actually 8 over 12. 8 over 12 is less than 9 over 12 is less than 10 over 12 is going to be. But I want to continue here. 7 over 12 we didn't change. But if I reduce the 8 over 12 by 4, I'm going to get 2 over 3. Then if I reduce 9 over 12 by 3, I will get 3 over 4. And if I divide this one by 2, I will get 5 over 6. And I compare the numbers here. For the negative numbers, everything what we were doing in the previous 3 questions, it's going to be inverse with respect to operation. If we compare 3 over 5, here also the solution method, it's given here, it's given. If we compare 3 over 5, 3 over 5, 7 over 5, 2 over 5, and 8 over 5, with the biggest numerator, is the biggest number. If we say 8 over 5 is bigger than 7 over 5, is bigger than 3 over 5, and bigger than 2 over 5, it's going to be. But for the negative numbers, everything is going to be inverse, which is minus 8 over 5 is less than minus 7 over 5, less than minus 3 over 5, minus less than minus 2 over 5. It's going to be. For the negative numbers, what we are doing for the positive, we are going to do inverse operation. If it is bigger, I mean from the operation, if it is bigger, it becomes smaller. Here it is given also.